Continuing the tour of the SMARTFIRE environment, we now consider the SMARTFIRE CFD simulation. Just to show the case now loading into the CFD engine, I'll fire off that component using the Run CFD Engine. And the first thing that the CFD engine does is pass a geometry file, load in the command script, allocate memory, and then open the user interface. The software starts in a stopped state so that you can perform any additional configurations before the simulation commences. And just to talk a way around the user interface available to you, the main controls available to the configuration are in this left-hand control panel. We also have a status window which will update with values for variables, the residuals and monitoring point values, as well as showing the progress through the entire simulation. On the right hand side are graphs showing sweep values and time step values to monitor location, and also sweep residual and time step residual values for all of the variables that are being solved. There is also a visualizer, a 2D visualizer panel that shows a cut plane through the data and optional visualizations of data that is available. First thing to do when you're examining a CFD simulation is probably to set the visual that would be most appropriate for you. The default one is very seldom a very interesting cut plane, and in this case it would be more interesting to move the cut plane through the fire so that we can see the early evolution of the fire effluent and development. I'm also going to change the output to contour fill of temperature and then move the cut plane through the center of the fire. Because in this instance the simulation has a structured mesh, the movement is by cell index, so incrementing and decrementing the cell index by 1 moves the cut plane 1 cell higher or 1 cell lower. The limits of the cut plane can also be changed using the other extent boxes. When I'm happy with the visualization cut plane and the visualization display items, I can select OK, and the visualizer panel will update accordingly. To show the other options that are available for the controls of the simulation, there is a global panel which allows you to configure aspects of time control and iterations, as well as the monitor coordinate. There is control of the solvers in terms of relaxations and tolerances, and also different scheme. There are also some calculated variables which have additional settings. There are options to configure what is saved or displayed on the graphs. The plots allow you to see defined plots. In this case we see the plot that we created through the center of the door. And the visual panels we've already considered, which select the cut plane through the visualization domain. As the results build up, we may like to consider the Explore option, which allows you to examine the solution in any particular cell. This menu is resizable because there are a lot of options available. And we see in this case that you can move around a virtual cell shown on the diagram, so that a particular location can be viewed. The particular cell that is selected will have all of the values that I've calculated available, including the residual inside that cell. This menu is particularly helpful as well because you can select to see min and maximum values in such a way that the system will search for the cell where there is the minimum or maximum of a particular variable. We're now in a situation able to run the scenario, so pressing the start button will allow the processing to continue, and immediately we see the arrival of heat and the effects of the arrival of heat with changes in temperature, changes in buoyancy, and hence changes in flow. As the density inside the fire region itself decreases, so the hot air is displaced upwards, and we see the evolving plume. It's worthwhile noting at this point that although the visualization looks perfectly plausible, it is only valid once the end of the time step and a converged solution has been reached. So this intermediate state, partway through a time step, is not in itself a valid solution. It is an intermediate numerical solution, and at the end of the time step is the only time that you can feel confident that the solution has reached that state based on the acceptable convergence. Convergence is determined by considering the residual values in the status window or in the trends of the graphs in the sweep residual. Ideally, towards the end of a time step, you'd hope that these values are tending downwards, although they won't necessarily reach the bottom of the graph, and you would hope to see that acceptable levels of convergence in the residual boxes on the status window. As this simulation will take some small while to converge and complete, I'm going to allow this now to continue without the video, and I will come back to discuss the evolved solution at the end of the simulation. So we've now reached the end of the simulation, and you can see from the visual that the flow is fairly well established. The plume is leaning over slightly due to entrained air from the window, and the spill plume has developed outside of the window, spilling out into the extended region. Continuing the tour of the software and some of the other capabilities of the SMARTFIRE CFD engine, we can now see the operation of the Explore window. We'll expand this out so that a larger view can be obtained, and I'll zoom in. I'm showing the solids to show the context of the rooms. Now, as I previously mentioned, you can use the monitor locations to move the monitor cell around within the domain, and that will update all of the displayed values and residuals. But you can also use the search capability to find particular cells of interest. So, for example, we could find the maximum temperature, and unsurprisingly that's within the fire volume itself. Maximum pressure, again somewhat unsurprisingly directly where the plume is rotating into ceiling jets. There are a number of visualization options that we have not yet considered. You can actually create multiple cut planes in different windows. So if I enable another visualization, and then choose a cut plane in the Y direction and move this cut plane up to the ceiling, and then obtain a second contour plot and velocity field in another window showing this data. The graphs that we had previously created will be available as separate windows, and SMARTFIRE also creates a graph for each fire and for each vent. Previously mentioned when we were looking at the case specification environment was the restart capability. In the restart option, the list shows all of the items that have actually been saved and are available for restart. So if for any reason something had gone wrong with the simulation and further control was needed by the user to tighten down the time step size or to change relaxation factors, then you can actually restart from any of these saved locations and continue processing with a different control strategy. Results can be saved and the captures can be reconfigured. You can change the frequency of capture and change the items that are going to be saved. That ends the tour of the CFD engine.